Hey guys, on this tutorial, we're going to take a look at the 11 problems that are within the Albert 5.1 assignment. So let's get started and look at number one. Um, for this particular problem, you are asked to calculate the probability that a randomly selected person. So let's stop right there. Um, we're looking at all the people. Um, what's the probability that out of everybody, somebody's going to say that they love it? So you need to take the total number of people that said love it, which is right here, and then you want to divide that by everybody in the group. So hopefully that one isn't too terribly difficult. Let's take a look at number two. So anytime I see a problem where they give me a lot of probabilities and they also mention the probability of two things occurring at the same time, I tend to lean towards doing a Venn diagram. So let's take a look at what that Venn diagram might look like. So the probability of event A occurring versus the probability event, this isn't the prettiest handwriting, probability of event B. And then the probability of both A and B, I hope you recall that that is where the two overlap. And you're going to want to put a 0.3 in that position. So once you put a 0.3 here, you have to take into consideration that the probability of A, all of A occurring, let me change my pen really quick so that you see this. I guess, let's see, highlighter. So all of A is right, well, I guess I didn't get it. All of A is this whole circle right here. So that whole thing is 0.6. So don't put a 0.6 in the missing part. This has to be a 0.3 because 0.3 plus 0.3 is 0.6. And then all of B is 50%. This whole circle here is 50. So this should be a 0.2. And then what the question is asking is what's the probability of Johnny not getting a job from either company? So 100%. So 100% is everything. And recall from class lecture, the number that this question is asking for is outside of the two circles. So take that into consideration. I hope that helps you guys out some. Let's take a look at number three. So you have to know the definition of disjoint. That's the key word here. And all you have to know is that disjoint events cannot occur at the same time. So that's all I'm going to help you out with on number three. Let's take a look at number four now. So this is a conditional probability. So let's take a look here. The nice way of writing it in AP Statistics is we're asked for the probability that this young woman is in high school. So that's the probability, given that her favorite type is ballet. So the numerator has to be high school and ballet. And in this case, that's a 37. And then you want to divide it by the probability that she is only going to like, or that a person is going to like ballet flats. So the top is the intersection and the denominator is only ballet. Let's take a look at number five. There are a couple ways to think about question number five. So let's see here. if you want to use conditional verbiage, conditional probability verbiage. The way to do that is we're asked, what's the probability of getting A? Given you know that the child is, or the person is going to receive A or B or C. So what's the chance I get A, knowing that I have to get A or B or C? So the probability of A and A or B or C, the intersection of those two, is 0.30. And then you have to think about what your denominator is going to be. Another option is you only have 50% to choose from, so that's your denominator. It's kind of hard not to give the whole entire answer away on this one. So hopefully you guys get that, that big hint. Let's take a look at question number 6 now. So it's obvious that I am loving the conditional probability questions here. So we are asked to actually calculate, we want to focus on the question at hand here. What is the probability that the selected person will be on the honor roll? So you want to write it as honor roll. And the given information is if a student is selected at random from among those who participate in the music. So I know the person is in a music program. What's the probability that he or she's going to also be on the honor roll? So on the top, you want to use the probability that the student is both honor roll and music, and then you want to only divide by the probability of music. Let's take a look at question number 7. So this question is asking us for the probability that a person is male. So make sure you read that last part of the question. What's the probability that the person is male? So when you write it on your paper, that's the probability I'm looking for. The given part of the conditional statement is that the favorite genre is sci-fi or horror. So sci-fi or horror. So you want to look at their intersection for your numerator. You want to look at male and sci-fi or horror. So to help you out there, that's these two numbers here. We'll go on the top. And you're going to divide only by the total for sci-fi and horror. Let's take a look at number 8. So number 8's just like number 7 in the fact that you're going to have to do some adding before you divide. And your hint on this one is you're going to have to add on the numerator and add on the denominator. The probability you're calculating is, let's see here. What's the probability that an individual surveyed is a woman? So you're looking for a woman given that their perfect vacation is a beach or a cruise trip. So I'm not going to give you too many hints other than the fact that number 8 looks just like number 7. Let's take a look at number 9. Hopefully this one's not too bad other than the fact that you have to use the complement rule to first calculate the probability of winning an entree. And the complement rule is found by adding up all your probabilities and subtracting it from 100%. So we know everything but the entree. So add up everything you know, subtract it from 100%. That's the probability of winning an entree. Then you're going to take that probability and combine it with the probability of winning an appetizer. This one is not intended to be too difficult. Let's take a look at number 10, and we are almost done. So here's another example where I'm given a bunch of probabilities, which can be overwhelming, and I'm also given a probability that both occur at the same time. So what I think I'm going to do is draw a Venn diagram, just because that works best for me. So when I do that, this kind of looks like an earlier problem I talked about. Ooh, that's pretty sloppy. Sorry about that. My OCD is getting the best of me. Let me try this again and see if I can make that a little bit neater. So we have school A, we have school B. I always do the probability of both occurring at the same time, and that is 0.25. And the probability of getting into A is 40%, so that means that this has to be 0.15 because those two, hello Bill, 0.15 plus 0.25, and then school B is 55, so that must be 0.30 here. What's the probability she gets into A? So the probability of A given that she gets into B. So the numerator is going to be A and B together, and then the denominator is just B. But remember, just B is, or B is 0.55. So I hope that helps you out. Let's delete that and let's take a look at our last example. It's a long video. Okay, so I saved the toughest for the last, and we're throwing a lot of different probabilities on this problem. And in this case, it's kind of hard to do a Venn diagram. So because I have so many different scenarios, I would recommend a tree diagram. And I haven't gone over this in lecture yet, but I do want to show you what this would look like. So take some good notes on it. We will use this more in the future, this strategy. So let's take a look. Two things are happening. First thing is we have an athlete that either uses steroids or doesn't use steroids. So let's talk about that. I don't have much room, so they either use it or they don't use steroids, right? And according to the problem, 15% use steroids. So 15% use steroids, that means 85% don't. And those two numbers on the branches of the tree always add up to 100%. That's the first thing that's happening. The second thing that's happening is after we know somebody's using or not using steroids, they're either going to test positive on the test or they're going to test negative. Likewise, if they don't use steroids, they're going to test positive or they're going to test negative. Now, false positives and false negatives happen, unfortunately. Nothing is ever 100% accurate. So the couple of numbers that I do know according to my problem, let's see here. I do know that 98% actually test positive and use steroids. So this gets a 0.98. So if that's 98, this is 2%, because remember that the branches have to add up to 100%. The other number they give us, I believe, is, I feel like it was 8%. The drug test gives a positive result for steroids when the individual is in fact not using steroids. That's kind of scary. So let's talk. Where does that 8% go? They are going to test positive when they don't actually use, which means they're going to test negative when they don't actually use 92% of the time. The probability that's you're being asked right now is calculate the chances that a test result comes back positive. And this is what we're going to go over more in class, but I want to highlight for you. The first thing you need to know are, oh gosh, let's see if I can pick up this pen. Okay. The first, I guess I don't want to write today. Okay. Having a hot mess here. The first thing we want to do is get these two numbers, because that's a positive test result. Crunch those in your calculator and multiply them. So 0.15 times 0.98 gives us 0.147. Do the same here with these two numbers, and this is super ugly, I get that. Crunch those two out, multiply them. I think it's 0.068. And then to calculate the probability of a person using and getting a positive result is 0.147, or the probability who doesn't, a person not using, but still gets a positive result is 0.068. And then you're going to add those two numbers together for your final answer. It's a really sloppy solution, but it works. Well, guys, I hope that helped you out some, and I can't wait to see you in class in a few days. Take care.